All right, everyone, let's get the show started. Welcome to our DevOps office hours. It's March 10th, 2021. My name is Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator, and that means that we help companies own their infrastructure in record time by building it together with your team while showing them the ropes. If that sounds interesting, head over to cloudposse.com/quiz to get started. Again, that's cloudposse.com/quiz to get started. For those of you new to the call, the format is very informal. My goal is to get your questions answered, so feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/officehours. Again, that's cloudposse.com/officehours. We host these calls every week. We'll automatically post a video recording of this session to our YouTube channel. If you enjoy the content and want to support the channel, please hit those like and subscribe buttons. It helps us a great deal. We'll also follow up with an email that you can share with your team. So with that said, let's kick this off. I got a bunch of announcements. So last week I hinted at that our RDS proxy module would be published. And that is true. So if you are in need of using that in your environments, check it out. RDS Proxy has a few interesting use cases. The first use case is, first of all, for connection pooling, so your applications don't have to implement that. And is a fully managed service by AWS and works with both the RDS Aurora and Postgres and RDS Classic. There are some caveats with RDS Proxy. It won't work with RDS Aurora Global clusters. It won't work with Postgres 12, which is a disappointment. But aside from that, it seems pretty cool. The other use case is you can use the AWS RDS Proxy to do audited SQL sessions for humans. So it'll work with your RDS IAM authentication. You can enable enhanced logging, and then you can get a log of every SQL query run by your team against the databases sent to Cloudwatch logs. So those are the two use cases that we have for it. Any questions on RDS proxy? All right. Next module is the code deploy module that was also released. This implements at least one of the common scenarios for using code deploy for blue-green ECS deployment. And I believe there's an example, if you go to the examples complete here, for how to leverage the code deploy module for that purpose. The other announcement is our Bastion module was pretty bad and out of date, if I say. We have redesigned it from the ground up. I think it still has backwards compatibility for how it used to work. More or less, there might be a feature flag you need to enable for it. The key thing, though, that is different is that now it uses AWS Session Manager by default, sits on a private subnet with no elastic IPs or public access by default. So this is far, far superior, as we all know, than using the SSH-based methods, because this is based on IAM access credentials. It's not public, and it works both on the command line. You can use one of the many SSM CLI tools out there. A pretty fancy one, I think, is SSM Go. Or Go SSM maybe? Yeah, Go SSM. That was my bad. And it has a pretty awesome little selector, so you can automatically see all the instances available that you have access to connect to. Filter, click, and connect right into SSM there. Any questions on the changes to the Bastion module? All right. The other thing we did was we have updated our Cloudwatch alarms module to follow our current best practices of using YAML for the definition of your configuration. This is to reduce the number of feature flags that you basically need in your modules. So here's an example of what that looks like. Here are all the CIS benchmarks that we support so far for Cloudwatch alarms on that. And it's just defined as a YAML config. You can easily contribute your own additional metrics this way. And it doesn't take a single change to the Terraform module to do that. You can import our remote catalog, or you can use your own local catalog because that's how it works with the with that. So there's an example here using the Cloud Posse YAML config module, specifying the location of your catalog and the files you want to include, and then passing that straight up to the Cloudwatch alarms. Any questions on that? All right. The other really exciting announcement I teased out last week, and I'll do a little quick demo of this as well, is we have published the Getting Started guide for the Geodesic shell. Keep in mind, this is just a toolbox, just as you have maybe other toolboxes in your organization with CLI tools. The difference is ours has taken like 500 or 600 pull requests to get right. So it's been pretty hard for such a simple concept. But what's cool about this primer is you can literally get started in 10 seconds right now for using this. And we build up basically the use cases. Like one of the use cases for our toolbox is for local development. Another one of our use cases is to deploy it somewhere, possibly as your Atlantis base image, or your Spacelift worker base image, and then the third use case is anywhere you need to use your DevOps toolchain as part of a workflow or pipeline. So like in GitHub Actions, perfect use case for running Geodesic. So just thought I'd show you kind of what it is so it's less opaque. So here's my window. I'll see if I can make this a little bit bigger and visible. There we go. So going over to documentation, one of the nice things about Geodesic is we support a base image for Alpine Linux, which is what we got started with, and we were using that for the last 4 years or 5 years. But now we also support Debian, and I believe we also support CentOS as well. So in this example here, we're showing you how to use the Debian version. So in this case, let's see here. So I'm going to start a shell using Geodesic. And there's my terminal window. Pasting in the command. This is straight from the docs. I hit enter. So what this is doing is this is mounting my home directory into the container in /localhost. So we can continue using our IDE and using native tools as much as we want, but we run the commands we depend on from the containerized shell, and that way everyone on our team is using the same toolbox, is using the same versions of the tools, and it reduces the conflict of like, hey, it works on my machine. I'm not going to say it totally eliminates it, but it more or less does. So in this case here, it detected I have an SSH key and it's asking if I want to add it. I'm just hitting Control-C to abort that. Sweet, I'm inside the Geodesic shell. I got tools like Terraform. I got Helm. I got Helm file. I got kubectl. I got all that stuff, and it's just at a arm's reach away. But the other key thing that separates our shell from like, if you like, you could just go use any Debian image, right, and get more or less the same experience. But what we do depends on a wide range of tools. So like if we go to Cloud Posse packages, this is our distribution of like, you know, DevOps tools. And let's say you use Terragrunt. Cool. Geodesic is still a superset of that. So while we don't ship Terragrunt with it directly, I can just do apt-get install Terragrunt, and it installs the latest version. Okay, I guess we do ship it actually inside the package. The other rad thing about this is the tools are constantly changing. So so we automatically update these every 24 hours. and download the latest package and distribute it to our package repository. So you can see how frequently this is updated as the ecosystem is constantly evolving. If there's a package you depend on, and it's a single binary, we'll be happy to distribute it this way. Right now, our bias is really towards multi-arch binaries that are easily distributed, not like traditional package management. So we also do another cool thing, like inevitably you will need tools for different, like you might have multiple Kubernetes clusters, and you're supposed to use the kubectl that matches the version of the cluster or newer. So in this case, we can do things like apt-get install kubectl 1.19 probably here. And bam, it's installing that version. But okay, we got another cluster. I need 1.18 installed. So I'll just install kubectl 1.18. Most packages out there that are generic don't let you have multiple versions of the package installed at the same time. And the way we get, so now I can either call kubectl directly, or I can use dpackage dpackage, what is it, alternatives system, I forget off the top of my head how it is, to set the default command I want to use for my current session. So I think it augments the experience for admins or operations peoples using it. Any questions so far? Uh-oh, somebody's drawing. Raul? So the other thing I wanted to point out, and let's see here, how do we clear the annotations? Clear all drawings. There we go. Is we are going to go over here to look at localhost. And that's just my home directory, right? So if I go into /localhost and I can go into my dev folder, and I might have some Terraform code in here. I could run Terraform right against it because it's just what I have. So it solves that case. Another use case, like we sometimes deploy Geodesic as a pod in a Kubernetes cluster. Then we can just exec into it, and we have our full tool chain. You can deploy Geodesic as an ECS task and start a teammate session. This allows you then to exec into that ECS task remotely. If you're not familiar with teammate.io is pretty rad for debugging stuff. It lets you have a remote shell it's built on top of tmux, lets you have a remote shell into any system. So that's one of those cool things we have here. All right, that was going to be basically what I just wanted to point out. If you want to check out that tutorial, head over to Cloud Posse docs, click on the tutorial here, getting started with Geodesic, and we walk through how to do that. Cool. Any questions before I move on?
How do you guys handle, like, I could, or like your example of having different Terraform kubectl commands and versions installed. If I need that all the time, like, do you guys just install it every time you need it, or do you create kind of a forked that's based on Geodesic that is a little bit more customized, or what?
Yeah, so I'm going to create a, let's say your company's called Acme. How do you address Andrew's question, which is a great question. Thanks, Andrew. I totally just glossed over this whole part. So let's see here. So in this case, all I did was I ran Cloud Posse Geodesic Debian. So now we're going to start with a brand new Docker image for my company. I'm just going to say from Cloud Posse, Geodesic, latest Debian. We also have version pinned releases. You can do that. I'm just going to do this for make it easy. And then we're going to do apt get install Terraform 0.14, Terraform 0.13. I think we actually even have 15, the alpha available, but this is just an example for that. And yeah, I'm going to clear these markups. Yeah, if we can please stop marking up the screen, I'd appreciate it. Annotate, clear all drawings. Cool. All right, so we're gonna do doc. Oops, that might have even been me. I totally apologize. Here. All right, there we go. Docker run dash I. Oh, now I need to do docker build dash t acme latest doc. So this is just going to build that Docker image. I'm mixing up Linuxes here. Apt get install. So that's now creating the image, shipping with the tools that we depend on, and anything else. If you needed to add some scripts or binaries, that's all we would do.
Got it. Yep.
Yeah. And then just
then you would push it to your, your own Docker hub or whatever if you're going to use it a lot.
Yeah, and that's even that is optional here. So in this case, now I'm just gonna run acme latest that I just built, and that's gonna drop me in here. And now I have Terraform 0.13 available. So pretty cool. It's a Docker image. It runs anywhere you have Docker images. You're using WSL for Windows, or you're using Linux, or using Mac. Same experience. But doesn't that get tedious to type out all those commands? So that's why what we do is the default here is if I just run this, is it outputs a shell script. We're going to improve the communication of that and what that does. But all this is what we call the Docker bash pattern. So yeah, Jeremy broke it, so it doesn't work on old versions of Bash anymore. Blame Jeremy. Anyways, if I had a new version of Bash on my Mac right now for this demo, it would have worked. Oh no, sorry. I take this is mea culpa. So I had the IT here. It's not Jeremy's fault. It's the user operator pebcac right here. So the IT says it's an interactive terminal. So it's outputting a bunch of ASCII. So I need to remove the IT and then pipe it into Bash. And there it has installed a shell script now. Okay, I need to say, yeah, this is trying to use, well, so much for live coding on the example here for the forked image. I don't remember the syntax right off the top of my head. The gist of it is, if we just didn't try and do it with our custom image here, is I would just do this pipe bash. And holy moly, we got to fix the UX there. But now I can just run Geodesic as a shell script, and I get the same experience. So the idea with the wrapper script is just to reduce the burden on the operator for running it and starting the shell up. But we need to improve the UX there a little bit on communicating the usage, and that's on us. All right, let me move on to the next announcement then. Terraform Beta 2, yeah, still hasn't happened. Was kind of hoping last week, and not this week. However, 14.8 was released. Just had a few bug fixes. Nothing exciting. other announcement is jobs. We are really aggressively looking for, especially US-based subcontractors who love working with open source. Everything we do is open source. We also work with some pretty rad tech startups. They've raised over $1 billion, and they love what we do. If you are interested in, some change or new opportunities, I do suggest you check this out. Go to cloudposse.com/jobs, and look forward to talking with you. Other pitch is sponsors. We have launched sponsorship tiers as low as $1 a month. Do check it out. Go to github.com/sponsors/cloudposse for that. All right, let's move on to talking points. Got some good ones here. Perfect segue into a question that was asked earlier. I think last week it was. It was a good question by Jonas. Jonas was asking, as it relates to our Geodesic shell, like, dude, why are you guys using Alpine Linux? Because that really sucks for interactive shells. It was really designed for server environments. I agree. And then wait, if you're promoting it to be a shell, why are you using Bash? Because Bash is not that cool anymore. Why aren't we using something like ZSH, power level 10K, etc.? Yeah, I got serious FOMO there too. I know. We can up the game a little bit on the syntax, on the bling on our shell. I think for right now we're going to stick with Bash just as a lowest common denominator for that purpose. But another point you were bringing up was that thing with Alpine. Exactly. Totally get it. A lot of stuff works very poorly in Alpine, Node.js. The AWS Clive v2 doesn't even run flat out, hard stop, does not run in Alpine. So yeah, that expedited our move to support Debian. All of our packages are distributed for Alpine and Debian and RPM now, I think. So to check that out, just add the -Debian tag and you get a better Linux-based distro.
Yeah, we could actually consider swapping those going forward if we want to make the default Debian rather than Alpine.
Yeah, I'm not sure if we'll do that just because the large footprint of existing environments pinning to the latest. And
yeah, that's true.
Pretty fundamental change. I think it's better. If anything, we deprecate it so it just breaks. But I think swapping out what latest means in terms of going from Alpine to Debian is like it's kind of mean.
Well, that will break. That will break too. But yeah.
Yeah, that'll break too, but it'll be it won't be a soft break. Like, why is this like, it'll be like the image is just unpublished. And just to call out, so then, I'm in here and let's say your company wants to use ZSH. Nothing's stopping you. Just apt-get install ZSH. Start ZSH. And wham, I'm in a ZSH shell. We don't have any of the customizations for it, but this is where super easy now just to install Powerline and do what you want. The idea is that Geodesic isn't forcing your hand in any way. We're not forcing you to use Terraform. We're not forcing you to use TerraGrunt. We're not forcing you to use Kubernetes. We're not forcing you to do anything. It's just a pattern. We're saying use a toolbox for distributing what you depend on for your organization, so you turn a 3-day onboarding experience into a 5-minute onboarding experience for your developers. All right.
How far do you take it with your organization? Do you say, you can use this if you want, but you don't have to? Or do you say, I want you to use Geodesic so everybody is identical?
Yeah, no, we have, imagine in our case, we deal with, a dozen or more concurrent engagements with customers at different versions of Kubernetes and Terraform. And it would be impossible if we said like, hey, just you get to choose if you want to be native or use Geodesic. So we have a hard rule. Look, we'll deliver a working solution with Geodesic. Then it's then it's an exercise up to you for how you want to run that natively. But As soon as you go native, it's this thing. Hey, why is it working in Geodesic but not on my workstation? Or hi, why is it working on your workstation and not my workstation? And I hate all those conversations.
Yeah.
Or somebody, they were doing an experiment on their own time, playing with Terraform 0.15, forgot they set Terraform 0.15 as their default, and because you're probably not practicing GitOps yet or something like that, they run Terraform 0.15 on a workspace in your organization in production, and now you're automatically running Terraform 0.15 on your production EKS. Your module for your production EKS cluster was provisioned with 0.15. Sorry. So obviously lots of ways we can fix that. Strict version pinning would be a better first start to it. Yeah, strict version pinning in the root modules. All right. Let's see here. Next question would be Andrew. You had a good question last week. You brought up. Can get some feedback on maybe. This is a controversial statement, kind of like, when are features considered done? Should they only be considered done when customers are getting value out of them? And it's a philosophical point. I'll list kind of my opinion on it from just a transactional nature of this. We got to get things moved to done in Jira. I don't want things forever in some state there and tracking it. I think this belongs somewhere else in however you track it. This is not necessarily what you're asking, but if features aren't considered done until customers are getting value out of it, then I guess that should be tracked somewhere else, and there needs to be a KPI with it.
Yeah, that's fair. I think maybe a better I think maybe a better way to pose the question would be, is it in a DevOps world, is it ever valid to say something is done by just handing it off to the next person in line who is responsible for it or whatever? Like, so we're not fully DevOps yet. We have devs and we have ops people, and our devs are handing off things to the ops people and calling it done, and then if there's a miscommunication on when it was supposed to get deployed or whatever, 3 weeks go by and they don't have any visibility on it anymore because it's dropped off of their board because they called it done.
Yeah. Andy, I bet you have some opinions on this one.
Yeah, I'm interested in I was interested in the problem that Andy just described, where he's having this wall between devs and ops, and there's not clear handoff. There's probably other tricks and mechanisms to smooth out those, barriers between those groups, and the tool could be definitely one option. But it's usually like, if there's no communication, if there's just no consequence, or if there's little accountability on the dev side. And I also think it's a two-way street. If the ops team isn't receiving what's being handed to them, it has to go both ways. So
yeah, collaboration. And then sometimes these systems aren't two different systems. Like, they're on some archaic ticket management system internally. You're using Jira. Marketing is using Trello. You don't have a single pane of glass for ensuring something gets done.
Yeah, I think this also goes back to something I think I've said on a couple of these office hours before, is that look to figure out a way where deployed does not mean released in your code. Use feature flags so that you can, as a DevOps person and as the developer, you can feel confident to deploy your code that has new features in it all the time. And then it's up to the business owner of that new feature to actually turn on the feature flag, to actually release it to users, and do all the things around that make sense, like canaries and being able to finally monitor a control group versus the people who are using the new feature, etc. But the more you can drive towards that model of deployment does not equal release, the much easier your life will become overall.
that takes a very, which is, I agree with every point. I just want to emphasize though, that takes a very specific point of view, like that we're talking about web apps. But like in terms of any time you're collaborating on anything between teams, this is a problem, a breakdown in communication. I see it happen all the time. As far as the engineer's concerned, they did their work, it's done, but they're not the one responsible for delivering the outcome. Ultimately, some person needs to be delivering that outcome.
Yeah,
And
I think I'll just refine a little bit of what you said. I think that since we were talking about development, I think that applies to everything, not just web apps, but every sort of development out there. But if we're talking about other things, we can argue that maybe it's not as applicable. But I've seen like devs saying something's done. It could be like that feature could be feature complete from their perspective, but it's not deployed to production yet. And sometimes that's the dev's responsibility to do that. Sometimes it's a product manager's, et cetera. But
yeah.
decoupling we have to tightly look at like deployments in order to release this is a bad paradigm to be in, and it's really hard to roll back when you're in a scenario like that if you encounter things. So anyway,
I think I also described, yeah, I think I also described an NDR process where we try to have that differentiation between done and accepted. And it's nice in theory. It becomes another layer of overhead, right? But it is nice to get that official thumbs up from the person that you're building the thing for, that they accept the work. But it does become another cue that, you know, because you will do work faster than that acceptance happens.
Yep.
And unless, you know, you have a lot of discipline around that, it can just become another thing that becomes stale and is ugly to look at.
Yeah, I was wondering if I could chime in on here. I thought of like, in my experience, like 3 ways in which you could get a better communication and on the topic what we're talking about. One of them is get DevOps involved in the build release process and owning that, because like developers are further removed from the code, the less they understand it when it goes bad into production, the less interaction and knowing who owns what part of the code sets in. And so that also creates kind of a bi-directional communication rather than the typical serial communication where you tie a note to a brick and throw it over the wall and the ops get it. You know, the proverbial works on my laptop and you see a burning, flaming home and a little girl laughing and snickering. The other one, this is from BDD in QA. They have a thing called the Three Amigos, and it's also called like an agile kickoff meeting. And so have the DevOps or operational people involved in the early design of the component or feature, in addition to QA. So the QA will ask, well, how do I test it? What happens when you do this negative value? And the ops will have all the reliability or operationalization of that in the early stage. A lot of times the ops are just ignored and not even included for software that's developed with a operational capacity, which just sounds insane. It's completely anti-DevOps. Another thing is I look at this from the Spinnaker is really having a segregation of the CI process and the CD process. There should be 2 separate segregated pipelines, and it really allows you to rapidly develop both pipelines. A lot of environments, they kind of intermix them together and it becomes a convoluted spaghetti monster. But when you have separated pipelines, you could get into, well, the CI basically delivers the artifact and the CD deploys that artifact, but it goes through a code maturity model as, you know, as one method. And in that you go through the testing and the QA, you know, test it. And then after it gets to that, it goes into where you say ops will look at it and stress test it and chaos monkey it and all that stuff. And then the final stage is the blue, green, canary, all that stuff. And either one of those phases could reject the build or require humans to be involved to accept the build or whatever. And then that gets promoted to the next part of the CD pipeline. It gets deployed automatically, or, you know, human deployed, whatever. Otherwise, you just won't get past those gates. And those gates could be automated so you have less friction.
Yeah.
Yeah,
I identify with that.
I have one other quick comment that of things that I've seen that have worked really well to prevent throwing bad things over the wall is that the developers own their services in production as well. So that model also works pretty well if you can make that work. And you'll find that things like logging relevant error messages and logs and all those things happen very quickly. Those problems fix themselves when the developer gets woken up at 3 a.m. a couple of times because something stupid happened, and error states and automatically recovering from error states and all those things improve over time, because no one wants to be woken up at 3 o'clock in the morning. But if it's an ops person's responsibility, like, I don't care. But if it's my responsibility, I do care. Like that's sort of the model behind it. I've seen that work pretty well.
Andrew, Roth, do you think we covered this or any other things?
Yeah, no, it's a bunch of good stuff. In our particular case, it was, the actual case was, it was a Terraform module that a change had been made to it that just hadn't been deployed yet, because we have, this is the repeatable module, and then this is the deployment that uses that module. And we ended up saying, okay, in order to call yours done, you need to submit a pull request into the deployment project. And I think that's gotten us most of the way there. So,
yeah,
I mean, that's what we did. But I just wanted to get other feedback on, what other people.
Well, that actually ties a lot into also, or I don't think this is, to me, I see this tying into what Joaquin was talking about, is separating your CI from your CD. And like in the Argo CD pattern where you have your deployment repo and you're either committing to it or opening pull requests against it to ensure that something is deployed. So in your what you're doing there is opening the pull request to get that deployed, is keeping that CD process separate.
Yeah.
Nice. All right. Something I think we might have covered last week, but I did just want to talk about it one more time. Was Jeff Dyke was asking, in our pattern, kind of using this utils module and Terraform, reading these stack configurations. How are we getting around this fundamental problem that, look, there's no interpolation supported for backends, and we're talking about the Terraform backends. So what we talked about last week was how we handle that. And referring to our documentation now in Cloud Posse, I kind of want to just talk about the pattern or the way to think about these situations. So one of our these are the concepts that we've kind of codified in our own internally consistent vocabulary. So we have components and stacks, catalogs, primary versus delegated, the toolbox pattern I talked about earlier today with Geodesic. There's vendoring, but then there's generators. Generators, there is no one way to do it. It is conceptually a way that there's something that needs to happen that you don't want to type over 100 times over or document how to do it, but you see a way that you can programmatically do it. That is what we talk about when we talk about this generator pattern. You can use Terraform as your generator. So Terraform can generate your state backend config files. You can use some Python script or Bash script, lots of different ways. So that's how we solved it ultimately for Cloud Posse. So when we go over to Cloud Posse Atmos, what we do is we define in our configuration, in our own way, the backend configuration. Let's see if it's in. I keep making the same mistake. Backend. So this is a kind of oversimplified example here, but we have the concept of a backend block here, and then we're We have it. We can define the defaults for the backend somewhere else. And then we're overriding, like in this case, the workspace key prefix only for the VPC component. So here we're saying the workspace key prefix is VPC. But how does that make its way into Terraform? Well, this is a little bit, again, referring to what Joaquin was saying about separating your CI from your CD. So the fact that you need to have a static backend configuration without interpolation ties into your CI process. What it needs to do is it needs to generate your backend configurations. Or what we do is we just have the developers generate their backend configurations and commit those to the source control. So what that looks like for us is in Terraform, we have so in Atmos, which is our CLI that we use, it's written in a language called Variant that uses HCL. And then we just have a little job here that generates the backend configuration by taking that backend config from the stack config and generating a backend Terraform file called backend.tf.json. We literally just call JSON encode on the data structure and write it to a file. Pretty formatting it with JQ. Yeah. So you can do that in Python, you can do that in Go, you can do that in any language. The fact is something needs to do it. You can use TerraGrunt for it, right? TerraGrunt has its own way of, TerraGrunt has its own built-in generator pattern, and it can write that backend file for you. Or you can copy it from another location. Same thing, conceptually, generator. Any thoughts on that?
Yeah, as some of you probably know, I just got into DevOps pretty recently. I started off with TerraGrunt because that's what some other teams inside my company use. And I do feel like it is excessive for my needs at this point, but those generators for the back end are really nice and provide a lot of value because they do set up the repos for you, and you have a lot of functionality that you can link to where it is in the tree in your repo, those kinds of things.
Oh, 1 second. My son just hey, Elias. A little bit, okay? All right. Thanks, Evan. Any other questions related to this? By the way, Joaquin, your hand is up. Did you have a new question, or was that left over?
That was from what I responded to.
Okay, cool. All right. Next we have a hot button topic. I'm sure this will take us the next 15 minutes with lots of feedback. David Lozano was asking a couple weeks ago, what are the pros and cons of using Kubernetes over ECS? And they're just definitely pros and cons, right? And you got to first look at this from your organization's perspective and what you're trying to solve and what your needs are. Hey, if your entire team is using ECS or has used ECS in the past, they love it. It works for their mental model for how to do cloud operations, and you need to make this decision on what to do. Use what your team knows and understands. And if they want to use ECS, go with ECS. Kubernetes, it's a whole different beast. I'd like to say ECS is like Kubernetes training wheels. It gets you starting to think about how to have a consistent platform to deploy your applications. But it is very limited by comparison to Kubernetes. Let me give you some examples of that. I like to think about Kubernetes as being a framework for consistent cloud operations. And it's a framework because you can extend it with your own custom resources. Basically configurations that describe something you want to achieve. And then you can have your own operators that operate on those CRDs and carry out some complex business logic for how to operate. So you have built-in capabilities like deployments and secrets and config maps, these primitives. But you could create your own abstract concept of what it is to do a blue-green rollout. In fact, that's exactly what Argo CD does. As an operator, you can it enables this ability to have a rollout custom resource. And this is where, like in ECS land, you're a little bit at the mercy of what AWS provides. So AWS Code Deploy will be kind of helping you do something similar to what you could do with rollouts and in Argo CD. But the difference is that's fully managed by Amazon. Now, if you want to create your own custom resource that manages some Mongo database cluster and failover and promotion or something like that, how would you do that with ECS? How would you do that with Terraform? Well, you don't even get started with Terraform. In Terraform, what you would do is you would write your own provider and somehow run that provider on like a schedule or something. You would write maybe a Lambda that manages it, and this is where the really crazy Rube Goldberg apparatus of Snowflake Rube Goldberg apparatuses start. Versus in Kubernetes, this operator pattern is formalized. That's why the ecosystem is growing so incredibly rapidly, and there's a whole marketplace for finding all of these operators to do stuff for you. I feel like with ECS, you're treating everything like infrastructure and less like a platform. With Kubernetes, you truly are just building this platform, and then the tools you use on the platform are up to the end user. Some people might be using Customize, some are using Helm, some are using Argo CD, some are using Helm file. Like, it doesn't matter. It's a platform. So yeah.
I was just going to say that I've made an analogy before that I believe, in my opinion, Kubernetes itself is actually is a cloud that may run on top of another cloud, but it is its own cloud environment in and of itself. Like, if you think about it that way, because it has so many things for dealing with cloud functions and utility computing and all of that's how you should view it, probably.
Yeah. It just struck a chord. Like, I remember when I first got my head around Kubernetes many years ago, and I thought, oh man, this is so brilliant. It's Google's Trojan horse into every cloud environment for dominance. Just like Android was their Trojan horse into the mobile ecosystem as providing an operating system. And it's interesting because if we take a step even further back to earlier versions of AWS and cloud infrastructure and how it was managed, it was very much, how can we create a normalizing layer outside of the cloud and the cloud APIs? And that's when companies like RightScale came out and built platforms for that. And yeah, I don't know where RightScale is today, but they're no longer needed anymore, let's say. So when you're using, and look, we love Terraform. We use Terraform a lot. But using Terraform is a lot of this still like, how do we manage the cloud from outside the cloud? Versus Kubernetes gives you a level playing field once you're operating inside of that cloud, so you can just deploy your apps consistently inside of that.
I think, was it the question still on the ECS, right, versus Kubernetes?
Yeah, exactly.
There's some management, as far as the controllers and other things that ECS doesn't have. I mean, you could compensate adding Fargate to it, but a lot of the issues with ECS, they've been met with third-party open source products to compensate for the lack of features that ECS has, in contrast to what K8s have. And I always look at also K8s. I mean, K8s is like the abstraction, but if you look what you had to do before, it's like to do kind of the rollouts and the rolling updates and the user draining and all that stuff was basically a black art, and it was different per company.
Yep.
And so Kubernetes unifies all those processes that would be just really hard to do if you manage your own, Rails app with your copy straddle and your own homegrown code, spaghetti, bubblegum scripts. And there's just nothing else I think that's out there that really succeeded that offers is maybe Nomad. But ASG, especially for stateful, in contrast to state with stateful sets Kubernetes, there's nothing like it out there that I know of. ASGs and also Google's managed infrastructure groups can't manage stateful sets because they're state, and Kubernetes does that. I don't know if ECS could handle that as far as the state goes.
Exactly.
For web apps, maybe they don't care about that, but they do get a lot of that user draining and all those features.
Yeah, exactly. There's this whole ecosystem that is missing because everything in ECS world is pretty much a snowflake to the organization and the company versus everything in Kubernetes. That's why there's an ecosystem of hundreds of operators that everyone's collaborating on doing. It's beautiful.
Don't get me started on operators. Operators is a double-edged sword.
Yeah, it's a source. Okay, fair enough. Operators is a sore subject. I think.
Yeah. Good luck getting to work and CRDs upgraded.
Yeah, well, exactly. The SDLC of an operator. Yeah, the promise of that has not yet been delivered on. It's been a historically sad story.
Let's like say cough Prometheus operators upgrade cough.
Yeah, Prometheus operator, Istio has been a pain doing major upgrades there. Prometheus operators, yeah, you name it. Any kind of operator where you can't just uninstall it and reinstall it at a minimum was a pain. And the gist of it is that basically operators are extending your platform, and it's difficult. There's no way right now to run multiple versions of the same operator in your cluster. To do a smooth rollout. And that's why using operators today is a little bit scary if you are treating it as a platform and you can't do blue-green clusters. So thank you for holding it, keeping me honest.
So I think
Kubernetes is like cooking your own meal into your own kitchen. You can very easily cut your hand and make your house blow up.
Yeah.
ECS is like Uber Eats. You just
Yes.
get delivered food. You like it or you don't like it.
Yeah.
And like, let's be serious. Somebody that has to decide between ECS and Kubernetes is not going to run operators. Operators are an in-depth topic that is opinionated, and I will keep it at that.
Yeah.
If you can get away
it's not
with
entry-level Kubernetes stuff.
Yeah, like if you can get away with ECS, awesome. Do that. You're gonna have to stress about so many fewer things. It's awesome.
Yes.
If that is not enough, if you need to customize intense stuff, sure, go for Kubernetes. Also, ECS and Kubernetes are two different things. Because, like, what are we talking about? ECS on EC2s? I don't really like that. ECS with Fargate? Awesome.
Yes.
Kubernetes with self-managed nodes? That's intense. Kubernetes with Fargate is a different thing. So there are options. If you can do it in ECS, again, start with ECS. It is so much easier. You don't have to stress every 3 months that you have to do an upgrade. A lot of organizations are not ready for that. They are not at that level. And that's okay. You have one-ish clear way of doing releases and upgrades in ECS. That's it. You don't have to decide between 300 different operators that all do GitOps. And what the fuck is even GitOps?
Yeah.
It's easier, and we shouldn't diminish the importance of that. The fact that ECS is easier is a big advantage. Not everybody needs to, scale to 10 million containers and 500 clusters and manage it all with 300 different open source projects. Some people do. That's totally valid. But a lot of people don't. And just going to Kubernetes because it's cool, it's going to be super, 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 super expensive. And I say this as a Kubernetes consultant that is paid obscene amounts of money to fix broken clusters and broken companies. If you can go with ECS, go with ECS. If there comes a time when you need to migrate from ECS to Kubernetes because you have a service that is, that requires custom scaling on 500 different metrics with super custom logic on that, you cannot easily do that in Cloudwatch. Kubernetes might be a better option. Awesome. Move that service to Kubernetes. But you don't have to. You can start with something easier and then move on to Kubernetes if you need it. There's also the advantage of open source software that you discussed. Instead of your company writing your own ML platform on ECS or EC2s and spending 6 months getting that out and then maintaining it at the cost of, $1 million a year, and everybody joining your company having to upskill into that platform, that is terrible. Or you could go to Kubernetes and you can use one of the many very popular ML platforms where you can just take advantage of that. You can work with the community. New employees will already know it. The patterns are there. You can contribute. You get free features developed for a product that you're using. And those features are developed by other companies. You get free new features. That's awesome. Instead of you creating an ML framework inside your company. That's a bad idea. You should be taking advantage of the awesome open source software that's on Kubernetes. Yeah. But if you're running a web service, throw it in ECS on Fargate. Go have a coffee, relax, meditate a bit. See your kids.
Your monolith does not need Kubernetes.
I think the last argument is, the whole vendor locking thing, right? If you're
Yeah.
if you're in ECS and you've spent a ton of time with it and you've built it out a ton and you're invested in it, and Amazon Amazon goes and raises the price of ECS by 20%, you're over a barrel. You have no choice. You're just gonna, take
That
what
is
they.
such a terrible argument that I cannot stand it. If we all definitely should write our own operating systems, because what if Linux decides to kill Linux or something like that? It's not gonna happen. It's unlikely. AWS never raise prices. If they do, they're gonna be in a way deep hole. And the cost of doing that yourself, the cost of running your own Kubernetes platform, the cost of running your own S3, the cost of running your own database on EC2 instead of using RDS or Aurora, that's a lot. It become lock-in. The lock-in argument makes sense for a couple companies in a couple industries. Financial industries, you are obligated to run in at least one cloud because you're considered public infrastructure. Valid argument, not gonna deny it. But if a web company has to decide that, they have to do a cost analysis. And when you're comparing yourself with AWS and what you can do in terms of cost with your 100 engineers and somebody mentions lock-in, that is not valid. The cloud is not your enemy. They're your partner.
And
Otherwise, we all should be building our own OS.
It's a totally valid argument. I guess my point was, Kubernetes, you can run a Kubernetes cluster anywhere and it's mostly the same.
Mostly being
versus
operative.
it's a bespoke solution, in ECS. With RDS, you mentioned RDS and stuff. RDS is just a MySQL database or a Postgres database or whatever, right? I mean, they're offering the ability to run it in a managed way, but it's still just Postgres or whatever, versus ECS is a bespoke solution compared to one that's an open platform that can run anywhere.
Yeah, I just wanted to jump in as kind of jokingly with Kubernetes mostly the same everywhere, except for network, except for storage, except for load balancers, and also anything that's going to have to integrate to the back end, which are going to integrate differently with annotations or whatever, depending on the drivers that are available for that integration and provision. Before that, there was one comment about do RDF and all this stuff. Well, actually, strangely, in my company, we're doing our own bare metal just because of the cost of AWS. And we actually deliver our own database, so we use our own database. But we love Kubernetes because the stateful sets. It's nothing like it out there. And so we're doing like kind of a one type of tier set of customers. Our database now is going to support multi-tenant, and it just makes sense to lower the cost because of the automation we have of Terraform and Kubernetes and Ansible.
Cool. Well, we are about out of time here. I think we got one more minute, so I think I'm going to wrap up before we open up a new topic to talk about. Thanks everyone for participating today. I think we had a great conversation. I want to remind everyone to go ahead and head over to youtube.com/c/cloudposse if you want to subscribe to our channel and catch up on past office hours. Also, if you haven't yet joined our Slack team, head over to slack.cloudposse.com. And if you're looking to change things up a bit or looking for a new job, head over to cloudposse.com/jobs. See you all next week, same place, same time.
Take care, guys.
Thanks, guys.